Well, maybe tonight's my chance. Let's pretend I've never heard of the theory of relativity before. Where would you start?
Where would I start? I think I would start by asking you to look at your watch.
Okay. It's ticking.
Perfect. Now, Zane, if you want to understand relativity, you must first forget everything you think you know about time.
Like what?
We treat time like it is a giant master clock in the sky, ticking at the exact same speed for everyone. Yes?
Yeah, 1 second for me is 1 second for you.
Exactly. But it is not true.
What, really?
Yes, time is the great illusion. Time is elastic. It stretches and it shrinks depending on how fast you are moving.
Wait, stretches? Like, literally?
Literally. Imagine I am on a train, moving at an incredible speed, close to the speed of light itself.
Okay.
And you are standing on the station platform, and we both are wearing a watch.
You are on a train, and I am on the platform, and we both are wearing a watch. So far, so good.
Great. But the watches we are wearing are not ordinary watches with gears and springs. Imagine a very special clock.
Special clock? Like what?
Imagine the watch consists of two tiny mirrors parallel to each other, one on top, one on the bottom.
Okay.
Inside this watch, a single particle of light bounces between the mirrors, up and down.
So 2 mirrors parallel to each other and a particle of light bouncing between them.
Yes. Now, every time it hits the bottom mirror, the watch registers 1 tick.
I'm with you so far.
Good. Now, to me, sitting inside the train, everything feels perfectly still. I look at my watch and see the light bounce straight up and straight down. It traces a short, simple, vertical line.
Makes sense?
But you, Zane, are watching my train zoom past the platform.
Okay.
Think about the path of that light from your perspective. The watch is moving forward with the train, while the light bounces inside it. So, to you, the light isn't just going straight up and down.
Well, it's moving forward at the same time, so it's tracing a diagonal line, a zigzag, right?
Exactly. And a diagonal zigzag path is much longer than a straight vertical one. From your perspective on the platform, my light particle has to travel a much greater distance to complete a single tick.
Okay, but light is incredibly fast. It just covers the extra distance, right?
Ah, here is the cosmic trap. The speed of light is the ultimate ruler of the universe. It never, ever changes. It cannot speed up to cover that extra distance.
Wait, speed is just distance divided by time. If the distance gets longer, but the speed of light absolutely refuses to change,
something else has to give way to keep the equation balanced.
So it's time. Time takes the hit.
Beautifully said. Yes, because the light has to travel further, and it cannot move any faster. The duration of that single tick has to stretch out. Time bends to accommodate the light. Therefore, from your perspective on the platform, my seconds are literally taking longer to happen. My time has slowed down.
So time isn't a rigid ruler, it's a rubber band.
A rubber band indeed, a very stretchy one. And just wait until I tell you what gravity does to it.
I think I might need another minute before we pull that thread, assuming my minute is still a minute. Professor Einstein and I have only scratched the surface. There are still questions waiting to be asked, and answers worth hearing. If you don't want to miss the rest of this conversation, subscribe to the Visorium. Until our next conversation, stay curious.